Hi, Jason again. This is part 2 of the Crazy Clock build series. Let's look at the Cad design and what went into that. Okay, let's go over some of the design elements of the Crazy Clock. So we have two motors that drive. This one drives the big arm, so this is the minute motor. And then we have this one back here, which is the hour motor. Since these are a couple of planetary gears, the center gear does not rotate on the planetary gear system. And so the center gear and the outer gears have to be the same number of teeth. The middle idler gears does not matter how many teeth are on there. So that allows the hour markers to remain level as it rotates. Now it's the same concept with the bevel gears. So we have this gear in the center, and these gears on the outside are both the same number of teeth, and they go through a kind of S pattern as the drive motion goes, and that allows it to remain steady as it rotates as well. This prevents me having to write extra code and getting off, and makes it a lot easier to keep track of as far as during the design. These gears right here, there's two. This one inverts the motion, but also the reason why there's two gears here, there's actually one small bevel gear and a spur gear combo and a normal spur gear. These make the design more compact. Otherwise, I would have to have the same size gear upright. And it was just that was an aesthetic reason. Right here we have a limit switch, and that is hit by this nub right here. So this has a ramp on one side and a nub. So as it rotates to home itself, it'll hit this switch. And if it rotates the opposite direction, which while I was coding it, it was annoying to have it hit the switch, so I made this a ramp so it would be able to glide over the switch without stalling. This switch right here is hit by this little nub on the center gear, and what that allows me to do, when this rotates, it's a 1:2 ratio from the center gear to the outside hour markers. Since it's a 1:2 ratio, it doesn't matter where the gear is, it'll always rotate, and when it hits the switch, it'll always remain at 12 o'clock when it hits. Now in this model, it's not showing that, but that's how it's configured later. We have all of our electronics down here. So we have two motor drivers. There's only one shown here. This is where the real-time clock is. I ended up mounting it on the side. This is the Arduino. It's an Adafruit Metro Adafruit Metro Mini. So yeah, that's pretty much the main design elements. Then we go over how the bearings are. There are two ring bearings here. There's one here, and there's one underneath. And then there's two smaller skateboard bearings, one here and one underneath. So it's coaxial, so that allows the center to rotate without affecting the outside, just like a normal clock would. We have pillow block bearings here. So these are just skateboard bearings pressed into these little pillow blocks that were 3D printed. And then we have these housings here that actually they hold a skateboard bearing upright and one horizontal to support the shafts that these outer wheels spin on. These gears here have their own. They actually each one has a single skateboard bearing, so those rotate independently. So there's actually 4 coaxial shafts that are on this project. The numbers snap in with little pegs when, as you can see, there's little. Let me zoom in on it. There's little pegs on each number, so that way they wouldn't be misaligned when I went to install them. these guys, these cubes here, each have a number on them, so I knew when I went to assemble it, I knew how to where the numbers went and what orientation they went, because some of them could go in upside down. The minute marker, well, the dial, this is just like the dial on a traditional clock, except it's 1/3 instead of 360. As you'll notice, these minute markers, so this one's 0, 5, 10, 20, 30, etc. They're not evenly spaced, and that's because since this wheel, this whole minute wheel rotates at a constant rate, if I had these evenly spaced, it wouldn't read the time correctly. So what I had to do is get the cosine of the angle of wherever this would be at certain minute intervals, and just place them accordingly based on the cosine of the rotation of this. I'm not going to go into the math right now. It's if you know trigonometry, it's pretty simple. And then we have foot, which has outriggers so it doesn't fall over. This is a rather expensive project. I want it to be pretty sturdy. These, as you'll notice, these pillow block bearings here, they're separate from the center, and that was for two reasons. So one, this piece is so big that it wouldn't fit on my TAZ 5 print bed, but also this allows me easy access to change out parts, in which I had to do a lot. What you saw in the video was all the good parts and everything went together smoothly in the video, but trust me, there was a lot of mistakes made and a lot of trial and error that happened throughout the project. So that is the basic design of the Crazy Cock.